All right, this is a think, pair, share. So maybe try this one on your own um, and resume this video to see my solution to it. Okay, so calculating sample size with the population standard deviation known. So how many daily rainfall amounts in Boston must be randomly selected to estimate the mean daily rainfall amount? We want a 90% confidence that the sample mean is within 0.01 inches of the population mean, and the population standard deviation is known to be 0.212 inches. And write an interpretation. All right, so what do we, let's see here, what were we given? So at first, let's see here, how many daily rainfall amounts in Boston must be randomly selected? Okay, so that's going to be our need. So let's just keep going to estimate. We want a 90% confidence level. All right, and we might as well calculate the significance level. So what does the significance level have to be? So that the confidence level plus the significance level equals 1. It's going to be 0.10. And again, we might as well divide that in half because we're going to have to take that significance level and put it on two tails of our distribution. So that's going to be 0.05. All right, that the sample mean is within 0.01 inches of the population mean. So that is our margin of error. Our margin of error, when it says is within, it's going to be 0.01. The population standard deviation is known to be 0.212. So population standard deviation, which is sigma, is equal to 0.212. So what we need is actually what was outlined at the very beginning, which is how many daily rainfall amounts, what's our sample size, do we need to kind of fulfill all of these parameters. So we've got n is equal to z alpha 2 times sigma divided by e, and all of that is squared. Now, again, I'm using brackets here because typically if I use parentheses, then I'll use brackets to kind of denote a different level of grouping. Okay. But you have to be careful. You don't want to use brackets on your calculator because brackets on your calculator refers to matrices. And matrices is something that you'll learn about in higher math classes. So don't use brackets, on your calculator when you're kind of doing this kind of calculation. Just use parentheses. Okay, but I use brackets to denote different levels of grouping. Okay, and that's very common in mathematics. All right. All right. So, let's see what we are given to kind of tell us what we need to figure out in order to calculate sample size. So we need Z alpha 2, but we don't have that. We do have sigma that was given, and we have error that was also given. So what remains to be figured out is this Z alpha 2 score, which is a critical value between the confidence level and the significance level. So we can use these two together in order to give us that Z alpha 2 score. So to help us, we are going to draw this out. So not just to help you, but help your brain see what's going on. Confidence intervals, we need to have a two-tailed distribution. This is our positive Z critical value. This is our negative Z critical value with a mean of 0 in the center. our confidence level is 0.90. So confidence level is the area between the critical values. The significance level divided by 2 is 0.05, and that's the area in this tail. And then the other tail is going to have an area of 0.05 as well. Okay, so what we need is we need an inverse distribution function in order to convert an area into a value, which is our critical value on the number line. Okay, so let's go ahead and do that. On. Okay, let me clear this to get rid of all that stuff. And yep, so distribution functions, inverse norm, 0.05, mean of 0, standard deviation of 1. I'm going to use the area on the right because then that'll give me a positive z-score that I want to use anyway. So I'll hit paste and enter. And then let me go to the MemWorks calculator and go to the distributions app. Okay, so I'm already in the normal distribution. Let's see, mean and standard deviation of 0 and 1 looks good. And yes, I want an area to the right with an area of 0.05. I'll hit enter, and it'll change this value from the previous example. Okay, so I'm getting 1.645, which is the same that I got on the MemWorks. And I'm going to go ahead and store that into variable z. Like that. Okay, so that value is stored in variable z. I'm going to do the same thing on the Texas Instruments. So I'm going to hit the store button. So it's going to store my last answer here in variable z, and I'll hit enter. All right. And okay, so the z-score that we just calculated, the z-critical score, was 1.645. All right, so we're going to use that critical score up here. So n is equal to 1.645 times sigma, which is 0.212, divided by our error, which is 0.01. Make sure to square that. Okay. So I think this time, I'm not going to put everything into variables like I did before. So let's see here. I need 2 parentheses. Let's see, 1 parentheses for the squared and another parentheses for the numerator. And so that's going to be our z-score times sigma, which is 0.212, like that, parentheses, divided by the error, which was 0.01. Right parentheses. So that's the entire fraction. And now I want to square that. Okay, and I leave that up so I can use these values here on the NumWorks calculator. So I need to go to the home button, go up to calculation. Let me clear that just to reduce confusion there. And I need parentheses, parentheses. Okay, and then I'm going to use my z-score that I stored in variable z. So shift alpha plus, that'll give me a z times 0.212, parentheses divided by the error, which was 0.01. And I'm going to do right arrow once. That'll take me out of the denominator and onto the side of the fraction. And I'll put right parentheses. And now I want to square that. So I'll hit the x squared button here. And when I hit enter here, and I hit and execute here, should give me the same answer. This one is kind of rounding, which is interesting. So I'm getting pretty close, but slightly different answers. But anyway, let's see here. So we've got 1,215.98. So we get 1,215.98. And the rule is we always want to round up. So we're going to get 1,216. And okay, that's a little off from what I had before, but I think I was using a rounded value. So you can see how rounding during your calculations can change your answer a little bit. I think I had used 1.645 in this calculation originally. And that put it off by one, which is enough to get the answer wrong, right? Okay, so we'll put 1,216. And so we'll say that, so we need 1,216 daily rainfall amounts to record to have a 90% confidence level and a margin of error of 0.01 inches. Okay. So that concludes this think, pair, share. Let me know if you have any questions.